Hi, I'm Herbert Gross, and welcome to lecture number 5 in Gateways to Algebra, where today we're going to talk about multiplying and, in the same sense, dividing signed numbers. Again, it's very, very important to understand that many of the things that we're going to be applying in a new context are things that we've already used in an old context, but maybe we just were never made aware of it before. Remember we mentioned that things like 2 plus 2 is 4 only when they all modify the same noun? In other words, when the adjectives modify different nouns, we have to find a common denomination. Which, by the way, when we add fractions, that's why we need a common denominator. Notice the resemblance between the word denominator and the word denomination. But that's not our issue right now. But let's take a look at multiplication from the same point of view. Let's suppose that we've just learned that 13 times 2 equals 26. These could be, either one of these two numbers could be modifying a noun. You see, the fact that 13 times 2 is 26 says what? 13 times 2 apples is 26 apples. 13 times 2 tens is 26 tens. What if I had 13 feet times 2 feet? See, 13 times 2 is 26, and feet times feet. And by the way, this is going to motivate our next lesson, pretty much. It's called square feet. In other words, we're multiplying a unit by itself, and this is written square feet. See, 13 feet times 2 feet isn't 26 feet, it's 26 square feet. On the other hand, you see, 13 times 2 feet would simply be what? 26 feet. You see, think of 13 feet times 2 feet as finding the area of a rectangle that was 13 feet long and 2 feet wide. The area is expressed in square feet. And this is a very, very important thing to remember. See, let me just make sure I point this out to you. See, how much is 2 tens plus 3 tens? This is not meant to be a trick. How do you add? You add the two adjectives. Well, first of all, you need a common denomination. You add the two adjectives. The 2 plus the 3 gives you 5, and you keep the common denomination. So 2 tens plus 3 tens is 5 tens. Now, how much is 2 tens times 3 tens? You say, well, I'll just multiply the two adjectives. 2 times 3 is 6. Now, here's the place to be very careful. Do not say the answer is 6 tens. When we multiply the adjectives, but we also multiply the nouns as well. The 2 times 3 gives me the 6. What's 10 times 10? 10 times 10 isn't 10. 10 times 10 is 100. And by the way, notice that this is the case. 2 tens is 20, 3 tens is 30, and 20 times 30 isn't 60, it's 600. And remember how you were taught to do this? You multiply the 2 times the 3 to give you 6, add the number of zeros, 1, 2, and the answer is 600. Let's try one more problem. Suppose I say 200 times 3,000. The 2 times the 3 gives me what? 6. What's 100 times 1,000? What's nice about numbers like this, 100 times 1,000, just put the two words together. It's 600,000. And by the way, do this the way you were usually taught. 200 is written like this. 3,000 is written like this. And how were you taught to do this problem? Multiply the 2 times the 3 to get 6, then count the total number of zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The answer comes out the same, 600,000. But notice the mystery is gone now. See, the 2 times the 3 was the 6, and the 100 times the 1,000 was the 100,000. And by the way, this doesn't just apply to tens, it applies to anything. Suppose you're multiplying 2 4s by 5 3s. Let's do this thing the way we just said, multiplying the adjectives and multiplying the nouns. The 2 times the 5 gives me 10, doesn't it? The 4s times the 3s gives me 12s. So 2 4s times 5 3s is 10 12s. And 10 12s is 120. On the other hand, another name for 2 4s is 8, isn't it? Another name for 5 3s is 15. And 8 times 15 is 120. Get the same answer either way. And again, in terms of fractions, Weren't you taught that when you want to multiply 2/3 by 5/7, you just multiply the two top numbers and you just multiply the two bottom numbers? Let's just have a little quick review over here. The bottom number is the denominator, right? Denominator sounds like denomination, which is size. Size is a noun. Numerator doesn't sound like top. It sounds like enumerate. Enumerate means to count. To count answers the question of how many, and how many is an adjective. You see, when you multiply two fractions, what do? The same general rule. You multiply the two adjectives and you multiply the two nouns. Why do you need a common denominator when you are adding them? Because the rule for adding always says what? You can't add the adjectives until you have a common denomination. And since 3 and 7 both go into 21, that's why we rewrite this problem using 21 as a common denomination. But my main reason for telling you all this is you already know this in one form or another. Now what I want you to see is I'm going to use exactly that same principle to figure out how to multiply signed numbers. See, what do we know so far? In the signed number, the number part, the magnitude part, is the adjective, and the sign is the noun. Now what's interesting about signed numbers is there are only two possible nouns. The noun is either what? Positive or negative. If it's not positive, it has to be what? Negative. That's what's nice when you only have two. If it's not one, it has to be the other. See, what's the opposite of true? False. What's the opposite of in? Out. What's the opposite of black? It's not white. The opposite of black is not black. Because something doesn't have to be white if it's not black. There are more colors, aren't there? See, red is not black. Green is not black. You see what I'm saying? When there's two choices, if it's not one, it has to be the other. But if there's more than two choices in life, you have to be careful. For example, what's the opposite of beautiful? It's not ugly. It's not beautiful. The opposite of beautiful is not beautiful. By the way, the same thing works in school. What's the opposite of pass? It's not fail. It's you haven't passed yet. See, instead of saying, I mustn't fail, I mustn't fail, I mustn't fail, all you hear is the word fail. You say what? I haven't passed yet, I haven't passed yet. It's a very positive emphasis. You take a long strip of wood that's 1 foot wide and put it on the ground, and I'll walk clean across it. Take that same strip of wood, elevate it by 100 feet. I'll fall off of it. And the reason is when it's 100 feet above the ground, I get nervous and I say what? I mustn't fall, I mustn't fall, I mustn't fall, and all I hear is the word fall. So, in other words, there's a lot of advantages when there's a situation where what? If something isn't one thing, it has to be the other. But when there's lots of choices, it makes things a little bit tougher. The reason that things are going to be nice for us now is when we're looking for the noun in a signed number, the noun has to be either what? Positive or negative. Therefore, if it's not positive, it's going to be negative. And if it's not negative, it's going to be positive. And let's see how this applies. See, suppose I have positive 3 times positive 2. Let's write this thing out so I can see the noun separately. It doesn't look nice to say 3 positive as opposed to positive 3, but we're used to doing what? Writing the adjective first and then the noun. So even though this doesn't look right grammatically, 3 positive is just the way I'm writing what? Positive 3. So it's what? 3 positive times 2 positive. What's the rule for multiplying? We multiply the two adjectives. The 3 times 2, that's going to give me 6. What else do? I multiply the two nouns. That means I multiply what? Positive times positive. What must this noun be? No matter what it is, there's only two nouns. Positive times positive can only be one of two things. It's either positive or it's negative. In other words, regardless of what the sign is going to be, when I see positive 3 times positive 2, the 3 times the 2 tells me that the magnitude, the absolute value of my answer is going to be 6. The only choice I have is whether it's going to be positive or negative. But by using logic, the choice is forced on me. We've already agreed that positive 3 means what? 3 more than 0, which is 3 itself. Haven't we agreed that whenever there isn't a sign, it means that it's positive? Okay? So, if positive 3 means 3 and positive 2 means 2, positive 3 times positive 2 means the same thing as 3 times 2. Do we already know what 3 times 2 is? We know that that's 6. And isn't 6 the same as positive 6? Therefore, what is positive 3 times positive 2? It has to be positive 6. And why do we know it has to be positive 6? Because if it was negative 6, the answer to positive 3 times positive 2 would depend on whether you left the positive sign out or not, and we just agreed that you're supposed to be able to do that without changing anything. So now we know that in mathematics, for consistency, positive times positive has to be positive. Let me just show you one more fact before we go on. Let's suppose I asked you to fill in the blank over here. I say 3 times 6 equals 3 times blank. What number has to go into the blank here to make this a true statement? What must you multiply 3 by to get the same answer as if you multiplied 3 by 6? Isn't it clear that the only number that's going to work that way is 6 itself? If you take a number that's less than 6 and multiply that by 3, the answer is going to be less than 18. If you take a number that's bigger than 6 and multiply it by 3, the answer is going to be more than 18. The only way 3 times 6 can equal 3 times a number is if that number happens to be 6. And you say, well, that's great, but what does that have to do with signed numbers again? Well, now we want to multiply positive 3 times negative 2. Let's see how we can do that one. Well, positive 3 means 3 positive. Negative 2 means 2 negative. I've just abbreviated the words positive and negative so they won't take up as much space. What's the rule for multiplying? Don't we still multiply the adjectives? The 3 times the 2 gives me 6. And that's interesting. No matter what the signs here are, as soon as the magnitude is 3 and 2, we know that the product is going to have 6 as its magnitude. The only thing that's in doubt is the sign. Therefore, positive 3 times negative 2 is either going to be what? Positive 6 or negative 6. My claim is it has to be negative 6. Why does it have to be negative 6? Well, for the sake of argument, let's just pretend it was positive 6. Okay? Suppose positive 3 times positive 2 is positive 6. We already know that positive 3 times positive 2 is positive 6. So if this was positive 6 and this was positive 6, these two things would have to be equal. Well, look at his positive 3 multiplying positive 2, his positive 3 multiplying something else, and the two answers have to be the same. Haven't we shown that whenever the first numbers are the same, the only way the products can be equal is if the second numbers are the same? The only way these could be the same is if what? Positive 2 was the same as negative 2. Okay? Is negative 2 the same as positive 2? Is a $2 profit the same as a $2 loss? No. So in other words, if positive 3 times negative 2, see, if positive 3 times negative 2 was positive 6, we see what? That positive 3 times positive 2 is also positive 6. That would lead to the contradiction that positive 2 equals negative 2. Since that can't happen, then we know what? That positive 3 times negative 2 can't be positive 6. But if it can't be positive 6, and the magnitude has to be 6, and there's only two possible nouns, positive or negative, obviously the only answer can be what? Negative 6. So positive 3 times negative 2 is negative 6. And by the way, if you want to see that from a more intuitive point of view, positive 3 means the same as 3, so positive 3 times negative 2 is the same as 3 times negative 2. Let's go back to profit and loss. Negative 2 is the same as a $2 loss. So if you have a $2 loss 3 times, isn't that the same as a $6 loss? And the $6 loss is the same as negative 6. So that's just a way, if you don't want to memorize the rule, to see what's happening over here. See, so positive times positive is positive. We just saw what? Positive times negative is negative. But multiplication doesn't depend on what order you multiply in. So if positive times negative is negative, if I reverse the order, isn't the sign going to stay the same? Negative times positive should also be negative. And that leaves us only with what? What is negative times negative? Well, there's a whole bunch of arguments you could make over here. You might say, gee, in the interest of fair play, let's call it positive. Why? Because that balances off the list over here. But fair play doesn't always work, not just in life, but in mathematics also. Remember what an odd number is? And an even number, odd means it's not divisible by 2. Even means that it is divisible by 2. If you multiply two odd numbers together, what do you get for an answer? It's odd, isn't it? See, 3 times 5. 3 is odd, 5 is odd. 3 times 5 is 15. Odd times odd is always odd. What's odd times even? See, 5 is odd, 2 is even. 5 times 2 is what, 10? Odd times even, by the way, will always be even. How about even times odd? Same thing, always be even. What's even times even? See, 5 times 4, 20. In other words, odd times odd is odd times even is even times odd is even, and even times even is even. Even though it's equally likely when you pick a number that it's either odd or even, the multiplication table is what? Always even, except when you're multiplying an odd by an odd. So this idea of saying it balances out may sound good, but it isn't always true. Let's see how we can show that negative times negative has to be positive. And we're going to do it the same way as we did before. When we start with negative 3 times negative 2, the one thing we know is that when we multiply the two adjectives together, the 3 and the 2, the answer is going to be 6. All we don't know whether is negative times negative is positive or whether it's negative. See, it's the sign that we don't know about. But it's either what? Positive or negative. And if it's not negative, it has to be positive. So let's do this by deduction. Let's assume that the answer was negative. Negative 3 times negative 2 is going to be assumed to be negative 6. Don't we already know that negative 3 times positive 2 is negative 6? Sure. A $3 loss 2 times is going to be a $6 loss. Well, if this is true, we're multiplying what? Two different numbers by negative 3, and the answer is coming out the same. That means that these two numbers would have to be the same, but negative 2 and positive 2 are not the same. See, again, a $2 loss is not the same as a $2 profit. Therefore, this can't be the case. And if this can't be the case, what's the only possible answer? We know that the magnitude has to be 6. If the sign can't be negative, it has to be positive. In other words, negative 3 times negative 2 has to be positive 6. All right? And let me see if I can show you that another way. Let's see the difference between multiplying by 1 and by negative 1. What's positive 6 times positive 1? Positive 1 is the same as 1. Multiplying by 1 doesn't change anything. So positive 6 times positive 1 is positive 6. Is 1 the same as negative 1? The answer is no. Therefore, should this answer be different from this answer? Yeah, if you multiply 6 by a $1 profit, you shouldn't get the same answer as if you multiplied 6 by a $1 loss. So the answers have to be different. But the adjective part is going to be what? 6 times 1 regardless. Therefore, since the adjective part can't change, and the only thing that can change is the sign, and there's only two possible signs, positive and negative, and it can't be positive, it has to be negative. So what happened when you multiplied positive 6 by negative 1? It changed the sign, didn't it? Let's try it again. What's negative 7 times positive 1? Multiplying by 1 doesn't change anything, so negative 7 times positive 1 is negative 7. Now what's negative 7 times negative 1? The answer has to be different because multiplying a number by positive 1 is different from multiplying it by negative 1, yet the magnitude, the adjective still has to be 7. All that can change is the noun. Since it can't be negative, it has to be positive. So what happened? Multiplying a number by negative 1 simply changes the sign of the number. Okay? And therefore, if you multiply a negative by a negative, you've changed the sign twice. And the key point is that changing the sign of a number twice gives us back the same number. Do you see why? If you're not changing the magnitude, there's only two possible signs. So if you go from the first sign to the second sign, see, first to the second, now you change the sign again. You only have two choices, so if it's not the first, the second, it must be the first. So let's summarize now. When you're multiplying, we're always going to multiply the adjectives, but if the two numbers are positive, the answer is positive. If the two numbers are negative, the answer is positive. But if one is positive and the other is negative, the answer is negative, right? Positive times positive is positive. Positive times negative is negative. Negative times positive is negative. And negative times negative is positive. And let's pause there for a moment and just summarize. In other words, whenever you want to multiply two signed numbers, what are you going to do? Without even looking at the signs, multiply the two magnitudes. That will give you the magnitude of the answer. Then what do? You look at the two signs. If the two signs are the same, the answer is positive. If the two signs are different, meaning they're opposites, then the answer is always negative. And please don't try to memorize, because you're going to get all mixed up. The reason being that the rules for multiplication and the rules for addition are different. People will say, I know why negative times negative is positive. I say, why? They say, because two negatives make a positive. Well, if that's the case, what's negative 3 plus negative 2? Isn't that two negatives? Why isn't the answer positive 5? And the answer is a $3 loss and a $2 loss is a $5 loss. It's not a $5 profit. It doesn't work that way. So again, let me just show you in terms of a summary type thing over here. See, if you add two negative numbers, 3 negative plus 7 negative is what? 10 negative. But if you have 3 negative times 7 negative, the 3 times 7 is 21, but negative times negative is always positive. Okay? See, negative plus negative will always be negative. Negative times negative will always be positive. What if you multiply a negative by a positive? The answer will always be negative. But if you add a negative and a positive, it might be positive, but it also might be what? Negative. See, 3 negative plus 7 positive is 4 positive. But what would happen if you had 3 positive plus 7 negative? It would be 4 negative. You see, when you're adding, different signs tell you to do what? Subtract the smaller magnitude from the greater. Then you have to see which of the two numbers, which sign number had the greater magnitude, because that's going to be the sign of the answer. But when you're multiplying, once you know that one number is negative and one is positive, it doesn't make any difference. The answer has to be negative no matter what else happens. And you see, the same thing happens even in elementary arithmetic. Suppose you have 1/2 plus 2/7. You can't cancel the 2's over here. See, you can only cancel the 2's if it's a multiplication problem. I once had a student do this problem by canceling the 2's and getting 1/7 for an answer. I said, why did you cancel the 2's here? He said, I was taught that way. Now, do you really think he was taught that way? No, but did he think he was taught that way? Yes, he had confused this with this and just mechanically did this. But let me tell you why this is a tragedy. It's not that he got the wrong answer, it's that the answer is absolutely preposterous. Look, 2/7 means you're taking 2 out of 7, doesn't it? You're already starting with 2 out of every 7. Now you're adding something positive onto it. Doesn't that have to give you a bigger number? In other words, whatever answer you get, shouldn't that be more than 2/7? How can the answer only be 1/7 if you already started with 2/7 and added something onto it? You see, when a person writes down an answer like this, it's proof that they don't understand what's going on. And by the way, we're getting close to completing the lesson over here. Let me just give you a few more things to keep in mind. The question comes up, okay, I understand how to multiply two signed numbers. What if you gave me 3? And again, we do what? Multiply them 2 at a time. -2 times -3 is what? It's +6. What's +6 times -4? The 6 times the 4 is 24. Positive times negative is negative, so the answer is -24. By the way, if you group them this way, -3 times -4 is +12. +12 times -2. 2 times 12 is 24. Negative times positive is still negative. The answer comes out the same. One more example. Now that we've learned to multiply and add and all this stuff, could you be doing more than one operation in the same problem? See, could you have what? You take +3, add on -7, then multiply that result by -2. Sure. Just, you have to remember what? Both sets of rules. Do the parentheses first. +3 plus -7. Different signs. Subtract the smaller magnitude from the greater. Keep the sign of the greater magnitude. That means what's inside the parentheses is -4. That's being multiplied by -2. The 2 times the 4 gives me 8. Negative times negative is positive. So the answer here is positive 8. And that wraps up multiplication. All right? Our time is up. We haven't even done division yet. Well, so what? Isn't division just the inverse of multiplication? What do you think the rule for division is going to be? To divide two signed numbers, divide as if the signs weren't there. Just divide their two magnitudes. And if the two numbers have the same sign, the answer will be positive. If they have opposite signs, the answer will be negative. And now we have the basic arithmetic for signed numbers. We're going to put that into our little bag of tricks. We're going to let you digest that for a while. And in the next set of lectures, we're going to talk about another topic in mathematics that we need to know. And I'm going to motivate that for you next time. We're going to build up gradually. Make sure you understand whatever we're talking about before you go on to the next lecture. And as I say again, till next time, study hard, enjoy yourself, and stay young.